So, as we are going to consider the applications of the solving of our triangles, remember, we managed to work with all the triangle rules. Now, this is an application which is used in navigation, which basically questions where you are given questions which are based on surveying and navigation problems. So, that is where we apply the triangle rules and not forgetting the basic concept of the trigonometry and also everything actually that you learned about the angles at a point, angles on a straight line, all those concepts, right? So basically in navigation, when we are to deal with the navigation concept, we consider a bearing being taken from a certain point. That is, a bearing is in the direction from one object to another. So in navigation concept, it's all about the bearing, where we are saying a bearing. All right, let me just write this one down. So we are saying a bearing is in the direction. The bearing is in the direction from one. So take note there, from, it's taken from one object to another. From one object to another. Okay. So basically, as we consider the bearing, these we can take the angles rotated in a clockwise direction, always from the north. So we are saying, let me consider this part of the bearing. So a bearing, all right, a bearing, thus a bearing can be given, is given, all right, as angles rotated, take note there, clockwise direction. So it must be rotated clockwise from the north. From the north. So the question is, what type of a bearing is this one? Where angles always are being rotated clockwise. And not only that, from the North Pole. Given the North Pole in this case, right? This is our north. Angles can be taken from the north direction in a clockwise direction, the way the clock moves. Remember, the clock is moving like this. The direction of the clock in a clockwise direction. That type of a bearing is actually considered as a three-figure bearing, right? Which is the basic concept of naming it, three-figure bearing. We have another type of bearing, which is the compass bearing, which uses the poles from north to east, from north to west. Is it from south to east? Is it from south to west? It's from a certain pole to another one with an angle given between the two poles. But this one, we are saying always, your angles will be taken from the north in a clockwise direction, always. A three-figure bearing. When we are given, let's say, a consideration of, I want you to just have the basic here. Let's say we are given the bearing. Let's say I'm just giving just an example here, the bearing of A from B. The bearing of A from B is 300 degrees. Or they can say the same statement here. They can say A has a bearing of A has a bearing of 300 degrees from B. So the most important point to note is from. From what? From, from where are you from? The movement is taken from which point? That is your starting point. So the angle of 300 degrees is at B, from B. The North Pole that we are going to have must be at B. So you can just indicate, all right, no problem, just like this. This is your North Pole. So let's say this point is where B is, because we are starting from B. So don't write B here, guys, all right? Just write, we know that this is where our B is. We can just write aside, okay? From that point B, going to A, we must move we must rotate 300 degrees. So as we do understand the concept of our quadrants, because here we have subdivided this into quadrants. 360 degrees divided by 4, meaning to say each quadrant has got 90 degrees in between. So as we move from the north, it will be 0 at the north in the clockwise direction. So that's 0, 90 degrees, 180 degrees, going this side, 270 degrees, back to 360 degrees. So you must now locate the angle as you consider the quadrants to say this angle is found in which quadrant? 300 degrees is found in between now. As we are moving this way, we are going to see between 270 and 360. In this quadrant, we are going to have our 360. So from B, 360 degrees can be like this. In the north, from the North Pole, in clockwise direction like this, 300 is greater than what? Is greater than 270. Here we are at 270. So it's greater than 270. So that's the angle for 360. So you can indicate with a line like this. All right. So that is from B going to A. The angle from B is 300 degrees. That is the angle that you just indicate. We are going to A. Yes, you can indicate the North Pole there at A, it's fine. But what is important here is how are we moving from one point to another given a bearing. If we are given, all right, let's say sometimes you can just given a basic bearing, all right. Let's say the bearing of A from B is 0, 30 degrees, which is 30 degrees like that. 30 degrees from where? From B. So from our North Pole that we are having here, where are we going to have the angle of what? 30 degrees from the north in a clockwise direction. So 30 degrees is less than what? 90, because this is 0, this is 90. So 30 degrees is less than 90. So we're going to find it somewhere there. From the north in a clockwise direction. Our 30 degrees may be somewhere there, but then we can join from this point, right, like that. So the angle in between here is 30 degrees. From where? From the point B to A. Where A is a North Pole also can be inserted. All right. So that is the idea of the bearing. I'm going to explain later on the relationship of these two North Poles, the one at A and the one at B. But let's consider another way that the bearing can be represented as we saw this one of the three-figure bearing where we consider the bearing that is being rotated clockwise from the north. Sometimes we can have angles maybe also given in terms of the north, south, east, and west. Right? So sometimes we can have these angles. All right, angles may be given, may also be given. All right, that's in terms of north, south. Those are the poles that we have, west and what? East. Okay, no problem. From the previous concept, there is no way that we listed something like north 80 degrees to the east. No, it was the bearing of A from B is. We just write 300 degrees. We just write 45 degrees, 30 degrees. We're just writing exact angles. When you're just given an angle, three-figure bearing, you'll be just given an angle there. You'll be just given an angle. All right? Here, you'll be just given an angle. You are the one who is to know when the angle is just given without the north, the south, the west, or the east. It is under a three-figure bearing, and that one is taken always from the north, rotated in the clockwise direction. But as the angles now are considered in terms of the poles that are surrounding that angle, is it the north, south, west, east? That one, it is a compass bearing. It is given or it is illustrated direct to the poles. Here we cannot say we are going to take this direction. No. It is different from what he is. Here it's a basic principle that you must follow on the three-figure bearing, this one. But on the compass bearing where we are just given the poles, you follow the way it is given, north 30 degrees to the east, north 30 degrees going to the east. Is it south 40 degrees going to the west? The movement is supposed to, the rotation is supposed to be taken in between the poles, from south to the west, from north to the east. So there we are not in a, we do not have an illustration to say whenever you answer this question, you are supposed to move from the north. You move according to the way that it is given there. First part is where you are moving from north to east, from south to west. That is a basic bearing that you'll be given. All right, so let me just try to give an example of this one and see how these questions they will give you basically a diagram, but on that diagram, you must also understand the meaning of every part that you're given. Let's say for an example, you're given that A has a bearing. A has a bearing of north 50 degrees, all right, to the east, all right, or that is from P, all right. A has a bearing of north 50 degrees to the east. We have a direction taken from a certain pole to another one. But from where? From P. So meaning to say, if I was to consider here, this is my north, okay? This is my south. This is our west and our east. So the question is, North and east. Where are we having these two? All right. Sorry for that. North, east. This is the quadrant where we have the north and east here. North, east. You must focus on those two. But you are moving from north to east as we have got this illustration. From north going to east. So we know that in between here, it's 90 degrees. So we just assume where 50 degrees can be as we are moving from the north. So let's say this is where we've got our 50 degrees. And we can have our line. From where? From P to where? To A. Wherever we are to reach here, that is where A is. So we are moving from north. So the arrow there is showing us from north going to the east. We are approaching the east in between an angle of what? 50 degrees. We are approaching the east. All right, no problem. Let me put it this way, because this one it will be like we are back to the three-figure bearing that we had before. Let's say it was south 40 degrees to the west from P. South 40 degrees to the west. So we're going to have our north pole as usual. Illustration of the north, right? Everything. The north, south, west, and what? And east. So the question is, from P, the angle that we are going to move from that P is south to west. South to west. South to west. So in this quadrant, but the direction is south to west. South to west. Your arrow must be pointing to the west. So from the south going to the west, we just approximate. Maybe this is where we have got our 40 degrees. Then we can join. So the angle in between here from south going to the west direction is 40 degrees. That's from what? From P to what? To A. So the pole is from what point? From which point? That's where the pole is being placed. West, south, the north, south, west, and east. If it was maybe they can give a south 30 degrees to the east, it means we are moving this direction going to the east. All right? So these are the basics, guys, you must understand. So from these two, you must be able to read and understand the meaning of these two together on the same diagram. Let's say we are given something like this, all right? A from B, which is maybe 30 degrees, all right? This is the north pole. This is B, and this is A. Then we are given here an angle of 30 degrees. I just want us to analyze what is happening here. Let's say this is what we had originally from the question. The bearing of A from B is, the bearing of A from B is what? 30 degrees, sorry. That is 30 degrees. Three-figure bearing. We just did, okay, from the north in a clockwise direction. Okay. But when we consider the same bearing as a compass bearing like this, which poles are we having from B? We have got the north, and we have where the line is, this line, it's in between what? North and what? And east. So you're saying from the north going where the arrow there, we are going to the what? To the east. So you can write the same bearing as north 30 degrees to the what? To the east. Same bearing. They can ask you to rewrite, or they can write any way they want. You must be able to analyze that. The bearing of A from B is 300 degrees as we had before. We saw that the 300 degrees was going to be in this quadrant like this. It was a 300 300 degrees as a basic three-figure bearing. The bearing of A from what? From B. It was 300 degrees. What about as we consider in terms of the poles, in terms of these north, south, west, east, as a compass bearing, the bearing of A from B is going to be what? How can we write it? A from B here. So as we consider compass bearing, we must consider the poles where it is found in between. It is between the north and what? This line, the west. All right, remember here I've got the west. This is our south, this is our east. So where are we situated here in this quadrant? So it is either you're going to take it west to north, or you're going to take it from north going to what? To the west. So if you take it from north to the west like this, what is the angle in between? So we can say the bearing is north. We need the angle here going where? Going to the west. What is the angle here? As we are going to the west, what is the angle in between? Remember, guys, angles at a point, that's where trigonometry part plays a role. We talked about these angles at a point, they add up to 360 degrees. So from 360 degrees, subtract 300, you are going to have what? 60 degrees. So that's north, 60 degrees going to the west. So that is how we play around with this bearing concept, like just a normal understanding of these two. They can be written on the same statement, and you analyze it in the way that you understand. And for calculations, fill in the angles, all the angles that you can, using any applicable way to solve the problems. That's from our solving triangles, from our trigonometry concept, anything that we understand, geometry of straight lines. Remember your grade 9 mathematics, geometry of straight lines. Why am I talking about this? Because we are saying these are two poles. I want you to understand this last part, the relationship between what? Between the north poles. Relationship between the north poles. Okay? As north poles are being drawn at both the north pole, the north pole, the north pole, like that. From our geography, we do understand that these north poles will never meet. They will never meet. Meaning to say, they are parallel mathematically. We are saying they are parallel to each other. So if the north poles are parallel to each other, therefore, the geometry of straight lines can be used. Knowing the understanding of our parallels is important. Now, that understanding on its own will be important. Let's say you're given the bearing of A from B, you indicated that part, and all right, we have got our north pole somewhere there. All right, this is our point B. Then the angle is indicated. All right, we do not even know the angle that we have there, but it is indicated. Where you are going, it is the point A there. And where you reach the point A, you can indicate a north pole as well, just like I said before. So this will be your point A. So these two, their relationship, that they will never meet, these two north poles, the one at A and the one at B. They will never meet. They are parallel. So north poles are parallel. Okay? So if they are parallel, what does it mean? It means we can use any concept of our parallel lines. The line drawn joining these north poles become the transversal line, which gives us from our phonics, remember, back to our grade 9 understanding of our angles, okay? Vertically opposite angles, alternate angles, co-interior angles, and also the corresponding angles can be formulated from there, as we do understand that the lines are parallel to each other. So you must go back, understand every relationship. Alternate angles, where we form a Z, they are equal. Alternate angles like this, as you can see. So the angle here and the angle here will be equal. The relationship of angles. You can see we are forming a Z also like this. This one, a stretched Z, this one. So the angle at this point and the angle at this point, alternate angles, they're equal. We talk of what? Co-interior angles, where we form a U like this or a C. Co-interior angles, they add up to 180 degrees. So considering this angle and this angle that we have here, they must add up to 180. So all that you must understand basic angles from a straight line, angles at a point. I want you to remember all those things. And before you answer the questions, I want you to remember everything. So if you do not remember, I want you to just save a basic, just revise your grade 9 geometry of straight lines. I always say for you guys who are in grade 11, your grade 9 mathematics, grade 10 mathematics, grade 8 mathematics, you are not supposed to close those books because that is where we are from. Those are the basics that you will need each and every time. So we have the videos, go back and revise the basics, all right? So without wasting our time, like I said, let me just have this one as a statement. When solving, then we can just look into a basic example. All right, let me remove this one. So when solving or for calculations, all right, so for calculations, try by all means to fill in the angles. Fill in the angles because you're going to form a triangle at the end. So you fill in the angles inside the triangle. Inside the triangle formed. All right, inside the triangle formed, and solve using any applicable way, and solve using any applicable way, any rule that you understand. So to fill in the angles inside the triangle, that part there where you fill in the angles, that's where you're applying all these understanding of your parallel lines, understanding of your geometry of straight lines. It helps you to fill in whatever triangle that is going to be formulated there. All right? Then you can solve using those basics of your solving triangles. Is there use of the sine rule? Is there use of the cosine rule? Any rules that we talked about before. All right? So let us consider the question that we are given. On this question, we are given that a ship travels 80 kilometers on a bearing of 28 degrees. So if we check the diagram is 18, the information here is saying 28. So you use what you are given from the information. So if you use the 28, I mean, this 18 is fine. We're just going to use the same way that I'm going to use this one as what? As 28. So this one It's supposed to be what? 28, according to way that we are given here. On a bearing of 28. We are not given northeast. What we just, when it is like this, we know the movement is taken from where? From the north in a clockwise direction. North in a clockwise direction. But when the poles are given north, south, east, and west, you follow how it is given there. But in this case, it was direct, all right? So this is from the north in a clockwise direction. That's our 28 degrees, okay? And then travels, so it moved this up, it's now at B. Remember, the ship travels 80 kilometers. It is moving, guys. Now it's at what? At B. So at B, that is where we are given, and then travels 190 kilometers. That is from B now. This is 190 kilometers on a bearing of 155. We are not given this north, east, or southward. So that's a three-figure bearing that we know it is taken from the north in a clockwise direction. This is the one that we are given from the north in a clockwise direction. So this is our angle of what? 155 degrees. So the question is, it has moved up to C. The ship started from A to B, then it's now at what? At C. So the question is, how far is the ship from its starting point? How far is the ship from its starting point here, where it started from? It ended at C, like this. So how far? That is the distance in between the 2 points, the starting point and the end point. That's AC. So the question, we are supposed to calculate or to find the length or the distance between points A and C. Guys, once you have a question like this, forget about all this navigation, bearing, this and that. Bearing does not answer questions. Bearing part helps us to fill in the angles inside of the triangle. Finding of this length, forget about that. Go back to your solving triangles. Think about the sine rule. Think about the cosine rule. That's solving of the triangle. But we cannot use these without all the necessary angles that are needed inside of the triangle. So let's figure out, how can we fill in the triangle? Remember, I say these two lines, they are parallel to each other. So we can see alternate angles are being formed. The angle at A, which is the 28 degrees, and the angle at B, let's just say at B there, let's just say B1, B2, and that's all B3. So the angle B1 and the angle, let's say A1 there, they will be equal. As you can see, alternate angles where we form a Z are equal. So angle B1 is equal to 28 degrees. Same as what? This A1. So there we have got 28 degrees. It's a piece that we have, a part of the angle of B inside the triangle. It's a part, it's a piece. Where is the other piece? The other piece is what? Angle B2, this one, the remaining piece. But we must find that piece, B2, from where? How can we find this angle B2? All right. If we consider properly for angle B2, we can see that this is a straight line. A straight line, this one. Angles on a straight line, they add up to 180 degrees. So 155 and B2, they are the two angles which lie on a straight line. So for us to find that B2, which is remaining, we can simply subtract the 155 here from 180 of a straight line, so that we have got the remaining angle B2, just like that, right? So the angle B2 was going to be 180 minus 155 degrees, which was going to give us 25 degrees. So the angle B2 here, that is the remaining part inside of the triangle, is what? Is 25 degrees. B1 and B2 together, they formulate or they give us the angle B. Inside of the triangle, angle B is formed, which is angle ABC. Angle ABC is formed. So ABC is what? 25 plus 28, which is 53 degrees. You add these two angles, 25 and what? 28. That is the whole angle in between here. It is what? 53. That's 53 degrees. We can't play around that. At A, we were limited. There's just one angle. There at C, we are limited. There is not even a way of finding that angle. So much limitations there. So the question is, with this angle and the two sides that we are given, can we find the length of what? AC. Using what? The two rules that we know in our solving of triangles, the sine rule and the cosine rule. Which one then is best? That is, we are back to the cosine rule. Look, guys, this is ABC. It is like this. Ignore all these other angles, these north poles and what? This is it's now a triangle. You are back to solving triangles. From A to B, it is 80 kilometers. From B to C, 190 kilometers. The angle ABC in between there is what? 53 degrees. So cosine rule can be used. Remember, where you are given an included angle. Where you have an included angle. Cosine rule can be used to calculate the third side. And under cosine rule, when you're calculating the sides, remember that ambiguous state does not even matter. Okay, let's just go straight. A squared is equal to what? B squared plus C squared minus 2BC, the cosine of A. The side to be calculated versus the angle, which is our included angle. So thus, AC squared is equal to the two sides that are formulating our angle, which is what? AB. So that's AB squared and what? BC squared minus 2 times AB times what? Times BC times what? The cosine of the angle in between, which is angle ABC. So that's AC squared is equal to AB from A to B, 80 kilometers. So that's 80 squared plus B to C, 190 squared minus 2 times our AB, which is what? 80 kilometers. Our BC, 190 times the cosine of the angle included opposite to the side that we are calculating, which is what? 53 degrees. Remember, your cosine rule, guys, I even dealt with examples under the cosine rule, under the sine rule. So as an individual, make sure that you watch the activities as you follow the playlist for the trigonometry, all right? So that was it. We can use our calculator there, simplify everything. That's AC squared is equal to, all right, let's see, sorry for that. Okay, let us just try and see what we have here. Okay, so as we can see, this was 80 squared. Okay, so that's 80 squared plus 190 squared minus 2 into, okay, you can just open the bracket for everything. 2 times 80, 2 times 80 times 190, okay, times the cos of 53 degrees like this, okay? That was going to give us 24,204 and so on. As we can see, that is what we have there, 24 204.8233. Okay. So to find now the length of AC, or the distance from A to C, introduce the square root, as we've got our AC. So AC was going to be the square root of the answer that we have, which is what? 155.58. If you round off to two decimal places, you can even shift, go to the setup, press 6, then press 2. All right, so that's 155.58. 155.58. The units as we are given before in what? Kilometers is given before. So this is in kilometers. So those are the basic questions. I want you to work out as many questions as you can as an individual. Try to figure out how these questions are given. Fill in the diagram. Fill in the angles inside the triangle formed and solve. Using any basic concept that you understand from the concept of your parallel lines and the geometry of your straight lines and so forth. So that is how to answer such typical questions. But where you do not understand, let's communicate from the comment section so that we can try to work out as more questions as we can.